This is a story about the physics of things that cannot be undone, and about one physicist who understood that truth better than anyone. On the 1st of September 1939, two events reshaped civilization in ways that could never be reversed. German tanks rolled across the Polish border that morning, igniting a war that would consume 50 million lives before it ended. That same day, in the pages of Physical Review, a paper appeared with the title, "On Continued Gravitational Contraction," and it proved that massive stars could collapse into objects from which nothing, not even light, could ever escape. The author of that paper would later stand in the New Mexico desert watching a fireball rise over the Trinity test site, and he would understand that he had crossed another boundary, an event horizon, not in space, but in history itself. 6 years separated those two moments, and both belonged to the same man. You believe you understand what cannot be undone, things like a broken glass, or a word spoken in anger, or the death of someone you love. But the question of why certain things move only forward, why the universe itself seems to have a direction, like an arrow loosed from a bow flying toward a target it cannot name, that question runs deeper than most people ever consider. The physics of irreversibility reveals something that changes everything once you see it. Time itself has a shape, and once you perceive that shape, you cannot go back to not seeing it. Most people miss something fundamental when they think about irreversible events. They imagine these moments as accidents or mistakes, as departures from some pristine, reversible order, and this understanding is precisely backwards. Consider a cup of hot tea cooling on your desk, with the heat flowing from the tea into the surrounding air, always in that direction, and never the reverse. No one has ever witnessed a cup of cold tea spontaneously grow warm by drawing heat from the cooler air around it. And here's the thing, there is nothing in Newton's laws of motion, nothing in the fundamental equations of classical mechanics that forbids this from happening. Each collision between molecules operates as a perfectly reversible interaction, and each tiny exchange could in principle run backward. The tea cools anyway, the heat disperses, the universe moves in one direction, and the movement is relentless. A physicist named Ludwig Boltzmann spent his life in Vienna trying to understand this mystery during the latter half of the 19th century. He perceived something that others had missed entirely. The arrow of time, this one-way direction governing all of our experience, emerges not from the laws themselves, but from the overwhelming mathematics of probability. When hot tea sits in a cup, its heat energy remains concentrated, with the fast-moving molecules clustered together in one small region. But the number of possible arrangements where that energy spreads out across the room exceeds the number of concentrated arrangements by a factor so enormous that no human number can capture it. And that's when the tea cools, not because the laws demand it in any absolute sense, but because the probability of the reverse happening is so vanishingly small as to be meaningless. Boltzmann named this measure of dispersal entropy, borrowing a term first coined by Rudolf Clausius, and he demonstrated that the increase of entropy gives time its arrow. The past points toward lower entropy, while the future points toward higher entropy, always and without exception. The law that entropy always increases holds the supreme position among the laws of nature. When someone points out that your theory of the universe disagrees with Maxwell's equations of electromagnetism, so much the worse for Maxwell's equations. When observation contradicts your theory, well, experimentalists do bungle things sometimes. But when your theory violates the second law of thermodynamics, there is nothing for it but to collapse in deepest humiliation. This should unsettle you for a specific reason. The distinction between past and future, which is the most fundamental feature of your conscious experience, is not written into the laws of physics at all. It emerges from statistics, from the sheer weight of probability pressing against us like an ocean. A century after Boltzmann, Claude Shannon at Bell Labs discovered that the same mathematics governs information itself. The reason you cannot unsend a message, cannot unlearn a secret, cannot unexperience a moment, operates on identical principles. Information carries thermodynamic weight, and entropy only increases. Shannon called it information entropy, but the mathematics is the same as what Boltzmann discovered in Vienna all those years earlier. The story grows stranger still in the 1930s, long before the Manhattan Project consumed the life of one particular physicist working at Berkeley and Caltech on problems that seem purely academic. Together with his student Hartland Snyder, he asked what happens when a massive star exhausts its thermonuclear fuel, when the fire at its heart goes out and gravity, patient and relentless, begins to crush it inward. Their calculations showed that if the star carries enough mass, nothing can stop this collapse. The pressure of electrons squeezed against each other cannot halt it. Neutrons packed beyond their limits cannot halt it. Nothing can. The star falls inward faster and faster until it reaches a critical radius from which not even light can escape. Einstein himself refused to believe this was possible. That same year, 1939, he published a paper in the Annals of Mathematics arguing that such singularities could not exist in physical reality. The father of general relativity rejected what his own theory predicted, but the mathematics in the Physical Review paper was clear. When you have enough mass in a small enough region, the collapse proceeds without limit, and the star tends to close itself off from any communication with a distant observer, while only its gravitational field persists. The boundary where escape becomes impossible now bears the name of Karl Schwarzschild, a German astronomer who first solved Einstein's field equations while serving on the Eastern Front in 1916. Schwarzschild died of illness months later, never knowing what his solution implied. Today, that boundary carries the name event horizon. Think about what that phrase contains. The horizon of events. Beyond this boundary, events occur that can never communicate with the outside universe under any circumstances. Information crosses that threshold and vanishes, not temporarily and not probably, but absolutely and forever. The event horizon functions as a one-way membrane in space-time itself, a door that opens only inward. The universe contains regions where irreversibility is not merely probable, but geometrically certain. In these places, the arrow of time becomes not a statistical tendency, but a fact of space-time structure. Inside that horizon, falling toward the center becomes as inevitable as moving forward in time, and the two processes become the same thing. The mathematics reveals something the human mind can barely accommodate, places where space itself becomes time and time becomes space. The future is not ahead of you in these regions, but beneath you, and you fall toward it with the same inevitability that once pulled you toward the earth. The beautiful part and the terrible part arrive together. When I read the Bhagavad Gita in the original Sanskrit, having studied under Arthur Ryder at Berkeley specifically to read these texts in their original form, I encountered a passage in the 11th chapter that haunted me for years. The warrior prince Arjuna asks the divine Krishna to reveal his true cosmic form, and Krishna obliges by manifesting as something vast and terrifying, a being of infinite mouths and eyes, containing within itself all of time and space. Krishna speaks in verse 32 with the words, Kalo asmi loka kshaya krit pravriddho. Every documentary and every article and every video about my life translates this as, I am become death, the destroyer of worlds. But this translation is imprecise. The Sanskrit word is not mrityu, which means death. The word is kala, which means time. The accurate translation reads, I am time grown mighty, the destroyer of worlds. The scripture speaks not of death as an event that happens at some moment, but of time itself as the ultimate destroyer. Time carries all things forward. Time cannot be reversed. Time consumes worlds not through violence, but through its inexorable passage. Krishna tells Arjuna that all the warriors on that battlefield are already dead. Not because anyone has slain them, but because time has already claimed them. The battle will simply make manifest what time has already determined, and Arjuna is merely the instrument. Standing in that New Mexico desert on the 16th of July, 1945, watching the Trinity fireball rise brighter than any light human eyes had witnessed, this passage flashed through my mind. The reason was not that I had caused death, though I had done exactly that. The reason was that I understood in that moment that we had crossed a threshold and passed through an event horizon of history. The knowledge could not be unlearned. What the Manhattan Project had achieved at Los Alamos could not be undone. Before Trinity, imagining a world without nuclear weapons remained possible. After that detonation, it was not. 3 weeks later, the same physics created crematoria over Hiroshima and then over Nagasaki. This is not a political statement or a moral judgment, but a fact about the structure of history. The work happened because it was an organic necessity. When you are a scientist, you cannot stop such a thing. When you are a scientist, you believe that finding out how the world works is good, that discovering what the realities are is good, that turning over to mankind the greatest possible power to control the world and deal with it according to its lights and values is good. But here's the thing about knowledge. You can refuse to participate and someone else will do the work. You can destroy your notes and the principles will be rediscovered. The knowledge exists in nature, waiting to be found, and once someone finds it, no one can unfind it. Nature keeps no secrets about the world itself. There are secrets about the thoughts and intentions of men, but nature keeps none. In some crude sense, which no vulgarity or humor or overstatement can quite extinguish, we had crossed into a kind of knowledge that cannot be unknown. The physicists had known sin, and this was knowledge they could not lose. The structure of that observation matters. The statement is not that we had committed sin, but that we had known it. And this knowledge, this terrible familiarity with what we had unleashed, is itself irreversible. You cannot unknow something. You cannot return to the innocence that preceded the discovery. This represents the deepest form of irreversibility, not the breaking of a cup or the cooling of tea, but the transformation of mind itself. The acquisition of knowledge that changes everything that follows operates on principles identical to thermodynamics. Something even stranger emerges when you consider what happens in your brain. When you learn something, when neurons form new connections and encode a new pattern, you create correlations between your mind and the external world. Your brain comes to reflect something outside itself, and the scattered information of experience becomes concentrated and ordered and held in the architecture of memory. This ordering of your mind carries a cost because the second law of thermodynamics is not suspended for brains. For every decrease in entropy within your skull, there must be a corresponding increase in entropy somewhere else. In the heat dissipated by your metabolism, in the disorder of the air you exhale, in the waste heat radiating from your body. The implication is remarkable. The very act of remembering and learning and becoming aware is possible only because entropy increases overall. Your ability to distinguish past from future, to remember yesterday but not tomorrow, is itself a consequence of the arrow of time. Memory is not separate from physics but embedded in it. The reason you remember the past and not the future is the same reason the tea cools and does not warm, and both arise from the same deep asymmetry in the universe. Shannon's information theory and Boltzmann's thermodynamics describe identical underlying reality. Much loose talk circulates about whether the laws of physics are symmetric in time, whether running the equations backward would yield equally valid solutions. At the level of fundamental particles, this symmetry appears to hold. A film of two electrons scattering off each other looks the same whether you run it forward or backward, and the equations of quantum mechanics and general relativity do not distinguish between directions. But this symmetry shatters the moment you consider systems of any complexity, the moment you have enough particles that probability enters the picture, the moment you have stars and planets and people and cups of tea. At this level, the asymmetry is overwhelming. Backward in time processes are not forbidden by any law. They are simply so improbable as to be unobservable in the lifetime of the universe. Boltzmann's insight carried such weight because he showed that the macroscopic arrow of time, the one we actually experience, emerges from microscopic reversibility through pure mathematics. The laws do not need to specify a direction. The direction arises from counting. In the gravitational collapse that Snyder and I described, published in Physical Review on that fateful September day of 1939 when the war began, we found that an observer falling inward would experience time normally. Such an observer would cross the event horizon and fall toward the singularity in a finite duration, as measured by their own clock. But an observer watching from outside would witness something different, would see their falling companion approach the horizon and appear to slow down, to freeze, to redden and fade from view, never quite reaching the boundary though. The boundary is all they move toward. Neither perspective is an illusion, because both observers accurately describe their own experience. Time itself flows at different rates in different regions of space-time. What this reveals is that time is not a stage on which events occur, but part of the event itself. Matter and energy shape it, gravity curves it, and at the event horizon, space-time bends so severely that the future itself becomes unreachable from outside. A question has pursued me through all the years since the war, through the hearings before the Atomic Energy Commission in 1954 that stripped my security clearance, through the long years watching the Cold War unfold its terrible logic. The question is not the one people expect me to ask. The fundamental question is whether actions exist that cannot be taken back, and if they do, what that means for how we should live. The universe provides an answer, though it offers no comfort. Some things cannot be reversed. The expansion of gas into a vacuum cannot be reversed. The formation of a black hole cannot be reversed. The detonation of a nuclear weapon cannot be reversed. The acquisition of certain kinds of knowledge cannot be reversed. But notice something in each of these cases. The irreversibility lies not in the action itself, but in the vast web of consequences that follows. The gas molecules could in principle rush back into their original container, but the probability is so small that we can call it zero. Irreversibility is a feature of systems rather than individual events. Every cup of tea that cools represents an individual loss of order that will never be restored, but the loss is not imposed by the laws of nature. It emerges from the combinatorics of the many. Both the man of science and the man of art live always at the edge of mystery, surrounded by it. Both have always, as the measure of their creation, had to harmonize what is new with what is familiar and balance novelty against synthesis. A deep and necessary truth holds that the deep things in science are not found because they are useful, but because finding them was possible. Knowledge and the power that comes with it carry intrinsic value, and we believe this even when the power proves terrible. Watching the debates about artificial intelligence today brings a strange recognition. The same arguments that circulated at Los Alamos, the claim that if we don't build it, someone else will, echo now in laboratories at Google and OpenAI and Anthropic. The same organic necessity presses on new scientists. The same approaching event horizon looms. The same question about whether certain knowledge once achieved can ever be contained hangs in the air. The arrow of time is not a curse. It is not even a limitation in any proper sense. It is the condition of possibility for everything we value. If time could run backward as easily as forward, there would be no memory. There would be no learning. There would be no growth. There would be no meaning to the idea of consequence. Actions would carry no weight because they could always be undone. Precisely because the tea cools and does not warm. Precisely because the knowledge cannot be unlearned. Precisely because we cannot cross back over the event horizon of history, our choices carry weight. Our decisions mean something. The universe gave us irreversibility, not as punishment, but as gift. The gift of significance. The gift of genuine stakes. The gift of a present moment that arises from a particular past and opens onto a particular future. Standing in that desert watching the fireball rise, I saw the arrow of time made visible. I saw entropy increasing in one terrible flash. I saw an event horizon forming not in space but in history. And I understood something I still struggle to articulate. We are not separate from the arrow of time, but are the arrow itself. We are the universe becoming aware of its own irreversibility. Every memory you form, every choice you make, every moment of consciousness you experience, these are the arrow of time seeing itself. Irreversible events are not accidents. They are not departures from some pristine reversible order. They are the universe expressing its deepest nature. They are time moving forward and creating the conditions for meaning. They are the price we pay for existence itself. And once you understand this, truly understand it, you see why the ancient Sanskrit scriptures spoke of time as the ultimate power. Not death, which is merely a moment, but time, which carries all things forward into whatever comes next. I am time, the destroyer of worlds, but also, and this matters, their creator.